pretty desolate, but at the same time beautiful. What we're doing here is we're testing a sensor that is going to be used for lunar landing.
Traffic against them. Go for landing. Over one. There it is. Son of a gun, right down the middle of the road. Outstanding.
The situation that was faced by Apollo was going into what we would consider very benign landing sites. A lot of people think that the new lunar landings will be just like Apollo, but the new landing sites are very challenging. The illumination at the poles is very dim. Sun angle is very low to the horizon, and because the moon has no atmosphere, shadows are absolute, and there's no diffusion of light.
Jeff to Moonraker 1. Well, this project is called ALHAT, which stands for Autonomous Landing and Hazard Avoidance Technology. And we're testing it on a helicopter that's flying over a lunar-esque terrain, lunar analog, seeing how good the sensor is at detecting these rocks out here.
Affirmative on the LiDAR ranges.
Copy that. ALHAT is a technology task that is building sensors and algorithms for landing on the moon, and in particular for detecting hazards during landing, as well as automatically estimating the spacecraft position by looking at the surface of the moon to see features and then matching them to an onboard reference to compute position. Kind of like people, when they navigate, they look at a map. We want to have the computer and the sensors do that automatically on the moon. This is all autonomous, assisting the pilot, helping them determine automatically where hazards are in real time. You know, it's really a new capability that wasn't possible at all in the Apollo era.
When you're getting lower in altitude and doing your final descents into the lunar surface, those are the types of trajectories we're trying to test here. We've got what we call a gyro-stabilized mount that the Hollywood industry uses for the movies, get their nice, smooth aerial shots. So we take the movie cameras off and we put our instruments on. So that instrument in the gimbal is the flash LiDAR, which is the main instrument we're testing right now. The flash LiDAR is an instrument that has a burst of light that comes out, a very, very short burst of light ejected from a laser aperture. 8 times a second, we're getting a 3D image. And we have a receive optics, exactly like a camera, so you're getting a 3D picture. So I'm in the back. I have 4 computers back there to look at it simultaneously, so it's a little bit hectic sometimes.
You never really know it's something until you try to see how well it really works. It's been a good test so far, and we're looking forward to getting into the meat and potatoes of the data.
I'm very excited to be working on this project because I really think it has a chance of being on the next lunar lander, and that's really why I work for NASA, is to build new technology that actually gets used. Going back to the moon and possibly onto Mars is really what I want to be working on.
When you're operating up there, it's pretty amazing to look down, especially out here in Death Valley and no vegetation. You're looking at this surface and thinking this could be the moon, some future astronaut a couple years down the line. When that happens, it's going to be a pretty amazing experience to say, yeah, I had something to do with that.